their own property.
Testing. 1, 2, 3. Testing. Testing. 1, 2, 3. Testing. All right.
Yeah, but surely that's not that much more up to saying that way. When it's in-house crazy. But if they were a Netflix, they would license their movies to Netflix. So that's what the money. But now that they're incurring all that cost,
yeah.
It's actually they don't want to pay. Let's say this is justice. They don't have to pay any like. No, but they can developers. All that stuff. Yeah, but surely that's still less than the cost of Netflix. And that's what I thought too, but it's not. Is it not? Developers are expensive. I guess also Netflix makes a lot of their own stuff. Yeah, they do. But back when they weren't, they were just buying.
Yeah.
And remember back when like streaming was just like $15.
Okay, ladies and gentlemen, let's get to it. Thank you for coming. It's good to see you. How is homework 7 coming? Is it coming okay? We just had, just a few moments ago, we just had our first 100% student make it all the way through. I was talking about this in 494 today. It is always really nice to see someone make it 100% of the way through a new assignment. It's a huge weight off of my shoulders. Anyone know why? And this actually gets back to game design.
The assignment is actually like be able to get 100 on, not for the fun.
Yes, that's right. It is possible, confirmed, for someone to clear the assignment. Now, that isn't much of a guarantee because maybe they got lucky or maybe there are other big issues in the assignment that will catch other people and prevent them from finishing. Maybe it's a 100% on Windows, but on Mac and Linux, it's actually broken. Until those come through, you don't know. But it is a huge relief to see that happen. And as it is the first time we're doing this course, you are the first person in history to complete the assignment, and that will always be true. So that's kind of cool. Perhaps we should call Guinness. Okay, so today we have, I think, what's hopefully going to be kind of a fun lecture. We're going to see how it turns out. I'm not sure. But what we're going to do is we're going to talk about a really cool, important engine called renderware. Then what I want to do, okay, there's this idea, there's this philosophy that says if you're going to make a game engine, you should make games, okay? And there are studios that do this, okay? In fact, our studio we're going to talk about today, Criterion, they are the makers of renderware, but they are also the makers of what? What is their famous video game series? They actually made quite a few games, but they're famous for one series in particular. Have you ever heard of a game series called Burnout? A big car crashing simulator game, right? Fast speeds, big explosions, beautiful engine. They're famous for that, okay? And if you've heard of Epic Games, if you've heard of Unreal Engine, right? Epic is famous for Unreal Engine, but what are they also famous for? In fact, what makes most of their money right now, this second? Yep. Fortnite, okay? And so we have a number of game engine makers who also make their own games. Tell me, how about this? Tell me one very prominent engine developer that does not make their own games. Jacob? Unity does not make their own games. They make some tiny stuff, but they're not a game maker. They just make the engine. And some people would be very critical of Unity and would point some of their recent terrible decisions to the fact that they just don't really make their own games, and so they don't really know what it's like to make games. They don't know what a game engine needs. So today, our mission is to take these game engines that we've been developing, we're going to sit down, we're going to make a basic game in them, and by doing so, we'll hopefully gain a feel for, okay, what's useful in this engine, but also what features might be missing. And I'm going to tell you right now, I was thinking through what we might make. Oh, we're missing some stuff, okay? We are missing some very nice stuff, okay? So it's going to be a little bit hairy. We're going to see how this goes, all right? Hopefully it'll go okay. Anyway, has anyone heard of renderware? So if you grew up kind of in the 2000s, mid-2000s, late 2000s, there's a very good chance you played quite a few renderware games. If you were active in gaming, around the time of the GameCube, PlayStation 2, the original Xbox, this was really the heyday of the renderware engine. I remember seeing their logo very often at the front of the game kind of intro screens. It was a workhorse. It was kind of the Unity or the Unreal Engine of the 2000s. It was initially released far earlier, though, in 1993. It was created by Criterion Software, who was acquired by EA in 2004, and they're basically defunct in 2023, sadly. But I want to show you this kind of brief documentary, really good one, a brief one on the topic of the engine, okay? And unfortunately, what caused its downfall. Let's go ahead and take a listen.
These games all have something in common: their 3D engine. More than 250 studios used it, and at one time it powered a quarter of all new console releases, helping to define a generation of games. Before Unity and Unreal, renderware was the little engine that could. But its dominance was short-lived. In 2004, it was probably the most popular game engine in the world, but 2 years later, it was effectively dead. How could something fall so far so fast? What went wrong with renderware? Originally, the renderware engine was neither a product of the games industry, nor aimed at that market. It was created by the camera company Canon at their European research lab. They spun it off into a subsidiary, with the aim of licensing the engine for applications like computer-aided design and virtual reality worlds. An early profile in Edge magazine sang the technology's praises in terms that verged on the hyperbolic.
Hard-nosed PC and IT correspondents at the launch couldn't believe what they saw was being generated in real time on a 486 portable PC. A new generation of software is around the corner.
But let's put this article in context. This was still the Windows 3.1 era. There was no DirectX, and OpenGL hadn't yet made it to home machines. Desktop 3D was something you only saw on Silicon Graphics workstations, or in movies. As well as the core group of developers creating the engine, the company soon started a small game development studio to apply that technology. Their role was twofold: producing commercial games designed to show off renderware's potential, and giving practical feedback to the engine team, so that they could tailor the toolkit to developers' needs. These early games, released on the PC, with a couple also on the Dreamcast, weren't particularly successful for the company, but games were just their side business, and they got some interest for their engine out of it. But though their early focus was on the PC, their breakthrough would not come on that platform. It was with the launch of the PlayStation 2 that renderware found its market. The machine's architecture was complex and unfamiliar, and writing code to display a simple 3D scene required a high level of expertise. Interfacing with renderware's libraries rather than the hardware itself was a considerable time saver. Trimming, the company claimed 6 to 12 months from a typical development cycle, and with the engine also available for PC, Xbox, GameCube and PSP, it made multi-platform development much easier too. Renderware was far from perfect. The convenience came with a performance hit, and it could be frustrating to work with, but the trade-off was often worth it. It was relatively affordable, so even a small team could get in on the action, and it was extremely versatile. You could build a sports game, a shooter, a strategy game, puzzler, platformer, RPG, flight sim. There were even 1 or 2 MMOs. Renderware-powered titles number in the hundreds, and include generation-defining games like the Tony Hawk series and the GTA 3 trilogy. As the company grew, the games they produced internally improved far beyond mere engine demos. To the public, making games was what the company was known for, and it wasn't long before the accountants thought so too. With the success of their destructive arcade racing series Burnout, they were now making more money selling games to the public than from selling tools to game developers. This combination of marketable entertainment and coveted technology was irresistible to buyers, and in mid-2004, Electronic Arts bought the company, which if you haven't worked it out was called Criterion, from Canon for $48 million. The acquisition sent shockwaves through an industry heavily reliant on renderware. Hundreds of studios, including Sega, Sony, Microsoft, Ubisoft, Activision, Rockstar, Konami, and Capcom, had renderware games in development, and overnight, it was owned by their biggest competitor. One magazine described the story like this:
Electronic Arts buys the rug devs are standing on.
EA pledged that support for renderware would continue uninterrupted, but studios were nervous about handing money to their biggest rival, and there was a trust problem too. Would the new owners really supply their best technology to their competitors? The CEO promised they would, but skeptical customers looked to switch to alternatives as quickly as possible. Before the buyout, Criterion had demonstrated the next generation of renderware, version 4, which promised to do for the Xbox 360 and PS3 what version 3 had done for the PS2. But the industry's concerns were proven correct. Updates to the renderware website ceased almost immediately. All talk of the new version stopped. Before long, EA terminated the licensing program, switching renderware to support mode for existing customers. Soon after that, it was described as effectively dead. And then, the final nail was hammered into renderware's coffin. EA licensed the Unreal Engine for its projects. Once the first choice for cross-platform development, renderware never made the promised leap to the next generation. Epic's Unreal Engine would fill the vacuum it left behind and become the market leader on the PS3, the 360, and beyond. We don't really know what EA's intentions were towards renderware. Some speculated that they bought Criterion to get their hands on the studio's IP and expertise in racing games, that they didn't care about renderware and deliberately killed it off to hurt the competition. But there's evidence that that wasn't the case. Of course they wanted the Burnout franchise, but they also, it appears, had big plans for renderware internally. They spoke publicly about deploying an enhanced renderware 4 as the common technical infrastructure across all of their studios. But despite their best efforts, Criterion's team were unable to keep up with the rapid evolution of the Unreal Engine. Renderware's capabilities were surpassed, and EA cut their losses, spelling the end of the technology and the team of talented engineers that had created it. The days of game development in renderware are long gone. It's been 6 years since the last game, a Chinese mythological RPG, was released on the engine, and over a decade since the last major title, Persona 4 Golden, hit the shelves. I found only one place it's still in use today, powering one of the longest-running 3D online spaces, Active Worlds. And apparently, Criterion's racing game pedigree is also a thing of the past. The founders left, a promised open-world vehicle game was cancelled, and the company was cut to less than 20 staff before being rebuilt in a different form, a support studio for other EA projects. They didn't even handle the recent remaster of their own Burnout Paradise. But EA recently announced that the studio, now employing over 100 people, was working on a new installment of the Need for Speed franchise. So while it's not really the same place anymore, maybe we haven't seen the last game with a Criterion logo. Criterion's Burnout games have never been forgotten, but through renderware, the company had a hand in many more favourites, helping to make that console generation the success that it was. Their work was critical for reducing barriers to development on the PS2, and I don't think they're appreciated enough for that. If things had gone differently, Criterion could have remained a major player in the game engine space. Perhaps with the right investment, the right decisions, and a lot of good fortune, renderware might have been a rival to Unity and Unreal today. But that's just a fanciful what-if. Renderware was the 3D engine that changed the world, but got left behind in the process.
It's interesting to me to think that sometimes the technical chops of your product aren't actually what's most important. In this case, right, everyone jumped off of renderware when EA made that purchase. Not because, the technology was bad, but because there was a lack of trust with EA. Not necessarily due to EA's fault. EA was just a competitor, a powerful one for many of those companies, those clients, and it was just never going to work out. Okay. Now, riddle me this: if you remember, EA does have a company-wide engine. What is it called? Frostbite. And I have read that a good number of the internal engine personnel from renderware went to help with Frostbite. So it is something of a successor, maybe. But it is very interesting, and just another reminder that sometimes it isn't about the tech, okay? Sometimes it's about your relationships with other companies, other people, that ends up mattering the most, okay? Anyway, very interesting example of relationships, corporate interference, and stuff like that, okay? There's some media I found that kind of shows us what the integrated editor looks like. It kind of gives me similar vibes to the Hammer editor that we saw with Source not too long ago, but maybe a little bit more integrated. You can see at the bottom we have some animation stuff. We've got a viewport. Looks like we've got a properties window and then a resources tab or maybe a hierarchy with templates, assets, events, all this good stuff. This just looks like a kind of a clunkier, older styled integrated engine. And so it's pretty easy to imagine. Maybe renderware could have been what Unity is today, open to everyone. I'll point out, wait, what's Unity's market cap? Hold on a second. Is it like 12 billion? $10 billion, okay? EA, I'm sure, would have appreciated having a nice $10 billion bump in their value if they had somehow found a way to make that work, okay? And to get the trust of clients again and to fight and maybe carve out a niche against the Unreal Engine. It's a shame that they couldn't, okay? But anyway, really cool to see this stuff. One thing that was nuts to see is that it looks like Renderware Studio 3.7, a download link is just up. It's just up on archive.org. So I haven't actually tried to run this, but maybe one of you can try and run it if you're interested and see, like, does it open? Like, can you actually run something with this old version of the Renderware editor? That would be absolutely crazy if you could. And I'm really glad that this software isn't completely lost to history, right? It's nice to just kind of find things kind of hidden away in the corner of the internet, preserved to some extent, even if maybe that's not supposed to be where it is, okay? Computing history is kind of a volatile thing. And, you know, someday all the NES systems in the world will stop running. And all we'll have is emulation and ROMs basically preserved to help us get some feeling for what those games were initially like. The hardware devices will stop. We'll never truly know what that experience felt like on an original CRT with original hardware, okay? And if emulation gets blown up for legal reasons or technical reasons or whatever, we might be reduced to just video footage to help and try and understand what made those titles so special. Hopefully it won't be that bad, okay? But preservation of software, the history of software is a big deal these days and becoming a much more important deal as time goes on. Okay, there's an old and crusty documentation site for a bunch of renderware concepts, the scripting language, and all that stuff. So you can read through some of this if you kind of want to get a feel for maybe what renderware was like to work with. It strikes me that renderware, at least with that documentation, with that version, was mainly kind of a graphics library abstraction. They didn't really have their own custom scripting language that allowed you to run your own logic. But when I look at the integrated editor, it seems to me that later versions probably did have something like that. In the absence of a scripting language, what becomes your scripting language? Anyone know? Renderware provides a nice graphics library abstraction written in C++. It doesn't provide any sort of scripting language like Lua or some custom language. So what becomes your scripting language? What are you going to write all of your gameplay logic in? Yeah, it's going to be C++, okay? That's just how it's going to be. And you're going to deal with those long compile times, possibly. The good news is your logic might be very fast, but you're not going to write it very fast. So hopefully your deadlines are nice and loose, okay? Probably not in this industry, though. Okay, let's go ahead and get to the announcements. I got a question for you. You've had some time to kind of look through Homework 7. I want to point something out to you. Have you noticed, you know how there's an image table, and it has some functions on it like draw UI. It has some advanced functions like draw UI X. The X stands for extended. It has new parameters. It can allow you to do more things. Well, guess what? Image.drawUIX does not have any parameter for rotating the image. Anyone notice that? Well, guess what? The moment you go to make a game and you're like, oh, I really want like my icon in the UI to like wiggle when you take some damage, right? It's juicy little effect. And you're like, wait a second, how do I rotate? And the answer is you can't. Okay, maybe you can fake it with the draw function, the draw X function, okay? But here's the thing. We are only implementing kind of a subset of engine features. We're being minimalistic, and the reason is that when I'm just making an engine over the summer, I can just put whatever I want in there. I can take as much time as I want. In this course, every single additional thing I ask you to do on an assignment is one thing that makes the assignment just that much harder, okay? So we're trying to keep it to a minimal set of things you need. And this is all to say that over the summer, there are probably going to be some features you wish you had, okay? Today, there are going to be some features we wish we had as we make our game. And that's just how it always is. Over the summer, you can go in and add those features, and I hope you will, because as much as you can learn from implementing an engine that I designed for you, designing your own features to add to that engine will teach you a lot as well, okay? How do you design a really nice API that's just really elegant to use? It's really intuitive. You don't need a ton of documentation. It's hard to mess the API up. You can't call it and have the engine explode, okay? There aren't that many things to forget, right? Is really a very difficult kind of UX in design and technical challenge, all wrapped up in one, okay? So anyway, I hope you look forward to that, and definitely don't assume that our engines at the end of it are complete, okay? There's more that can be done, but also don't assume that these engines stink, okay? Because you can do some stuff, as you have seen just in your test cases on homework 7. There are some real things you can do with this engine, even in its kind of minimalistic state. All right? Okay. All right. And when you go to design your engine and add things to it, okay? When you're no longer just trying to make the autograder happy, you're trying to make your users happy, remember this. Remember the wise words of Steve Ballmer, the Microsoft president?
Developers, 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 developers. Developers, 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 developers. Yes!
Okay, so yeah, Steve Ballmer is quite the character. Anyway, yes, so remember that in a very unique way, on this software product, your customers, your users are fellow developers, okay? You might refer to them as game designers if you want, but they are writing code, and they need to use your systems and the abstractions and the techniques you come up with, okay? Your mission is to give them simplistic, easy-to-understand tools that also have a great deal of power, okay? So that they can accomplish amazing, expressive things. Whatever they think of, they can make happen, and they can do so without having their brain explode or getting themselves confused, or without them writing a ton of bugs, okay? Okay, all right. So anyway, isn't that just really unique? Like usually you're writing software for like an accountant, or like you're writing a website that someone will, like your grandma might visit or something. I don't know. Here, you're writing software for the people sitting right next to you. And I think that's a pretty interesting thing, okay? Okay, so what I want to do today is I want to make a game with you. All right, I want to make a game. What does a game look like in our engine? Okay, tell me this right now. Okay, I want to know exactly what a game looks like in our file system. AKA, if you want to distribute a game made with your engine, how would you do it? And in just a moment, I'm going to show you how. How would you do it? Right now. Let's say you've got a Windows user in Vancouver who wants to play your game. How are you going to send them your game made in your engine? That's right. You're going to have the engine.exe, right? Game_engine_win.exe. And then you're going to have the resources folder there. But then if you just do that, it's going to crash immediately because you also need something else that's not there. Yes? Yeah, you need your DLLs in particular. Your static libraries have already been linked into the binary, okay? Your DLLs are linked when the program starts to run. If they're not there, your user's going to get blasted with a missing DLL thing, okay? In fact, I'm going to show you what the game looks like right now. You ready? Here it is. It's on my desktop. You see my game right here? You see that folder? I'm going to open it up, and what do we have here? We have a resources folder. We have a GameEngine.exe. Shouldn't that be GameEngine.win? Shouldn't that be? Why is it GameEngine.exe? I don't know. Anyway, hopefully this is the latest executable. Otherwise, we're going to discover some interesting things as we try and make this game. We've got all of our DLLs here, and we got 4. Now, I don't really like how these look. You know, like they're kind of clouding things up. I wish I could hide these DLLs, and you can, but it's a little bit annoying to make it happen. Okay, when I delete these and run, look at that. It immediately explodes, right? SDL2.dll was not found. Please reinstall the program, okay? Oh, goodness, it's going to do this for all 4 of those, too. I'm going to Control-Z to bring them back. When I run my engine, I get nothing. It also doesn't explode because unlike on the autograder, there is no SDL underscore user input .txt to tell it to fake a bunch of events that eventually quit the game, okay? But I can exit out right there. So this is our game. And if you were distributing this engine to friends, to family, to other game devs who want to use the engine to make their game, this is what you might provide, okay? And you would tell them in your documentation, hey, the first thing to do is you would go into the resources folder, right? You'd probably go into game.txt. And what's the first thing we want to edit here? Oh, hopefully, oh no. Yeah, hopefully we don't have a bunch of issues. Oh no, ripperoni. This is like the worst lecture to have a bunch of weird hard drive issues with Finder and Explorer failing. What's that? Maybe, but I don't really want to. Yeah, I guess let's try and restart it. Okay. This might be ripperoni, but I've come prepared because usually it gets messed up on the desktop. This is the instructor solution. Okay, so look closely. And what I can do is I can try and run it here if I want to. And here I can actually mess with stuff. So in the resources folder, the first thing you might do is go into game, for instance, and that works just fine. It's just the desktop that it doesn't like. I think it might be something with OneDrive getting messed up and trying to replicate it. Anyway, let's name our game. Let's call this my game. So the initial scene is basic. Okay, that's fine. And then let's render this, because right now our resolution is 100 by 100, and we might want something a little bit more normal, okay? Maybe, I don't know, like an 800 or something by 800. That's not really a normal resolution these days. But you might also want to add a feature in here that enables full screen, okay? So it flips us into full screen mode in SDL, so we can get a nice immersive gaming experience. Let's go ahead and run our code base here, run our executable, and look at that. We got a nice big screen. Now, I've actually got some components in here that are already doing things. Let's go in and just refresh this really quickly. Let's go sample actor, and let's call this sample component. If you were distributing your engine, what you probably want to do is you'd want to have some sample stuff in here, right? So sample component, and then that component could be just a really basic one that like prints a message every frame, right? Debug.log, and it could be like, you know, tick, okay? Now, how this works, if you haven't really spent much time here, is that this sample component has a function with a special name on update. This means that our engine is going to automatically call it if this component, sample component, is on an actor. And if we look at our scene, our initial scene, you'll see that, yes, there's one actor in our scene. It has that sample component. And that is how it goes, okay? When we run our engine, we don't have to recompile at all. We're just going to, you know, things are going to start going. Hopefully. Why did it quit though? Oh, it quit because I do have a SDL user input that's killing us here. So we'll get rid of that. Yeah, we will see if we can get some text to show up every frame. There it goes. Yep, sweet. So it's working, okay? Now, what you might want to do if you want to actually go and make a game is you might want to be able to draw it, okay? Draw a character. And that brings us to our first question of the day. We're making this game together. So what kind of game are we making? Well, let's start with what is our protagonist? How are we going to theme this thing? Okay. And I'm ready to go. I got Pixabay. I got chunky squirrels ready. What are we going to do, team? What's the play? We're going to make a game together. All right. What's the play? Let's go. Come on. We don't have. We got 1 hour to finish our game for EA. Okay. Otherwise, we're totally fired. We're gonna get canceled. Our team's gonna get wrecked. Okay. Yes. It's a robot. We got a robot game. All right. Let's also search on Open Game Art just in case we can see which results we like. We got a bunch of images here. That might be kind of nice. Look at this, right? We got this cool robot, a bunch of images. Now we might have to, is this going to be transparent? Let's open it up in, oh no. This is so awful. Why is my computer this way? Can I open up another Finder? I'll tell you, if you ever see a computer on like 50% discount, like you run. Okay. Okay. So we've got nice. It's all kind of transparent. Okay. So what I want to do is I want to see if I can get just this image over here. I'm going to go in, going to kind of isolate these images, delete the rest of these. I'm going to go into image. I'm going to go to zealous crop, and then I'm going to save right here, export as robot south. Okay. So facing south. Okay, I want to also see if I can get some of these other ones in here. So I've got a robot facing west, a robot facing east. Okay, image, zealous crop. Let's go to export as robot west. This one is. Let's bring us back out. Get some of these back. Okay, robot east. We might use these later if we got some time. Let's go to zealous, go to export, so robot east. And then I want to get, let's see if we can find the robot facing north, if there is one. There is, okay, so up here at the top, we got some robots facing north that look pretty good. And we just really need one of these. I think this is a floating animation. That's why there are multiple frames. So let's go to zealous crop. And then just give us all those pixels, robot north, okay? And that is going to be all we need for our main character here. So we have our images. Well, how are we going to use them? Let's go ahead and let's copy them and hope we don't explode here. Let's go ahead and copy them into our resources folder. Remember, we have to create the images folder, which is a special folder. Anything in this folder is available for us to load at runtime. Okay, so we now have some images to draw. Let's see if we can draw them. In order to draw them, we're going to need a new component. So I'll copy the sample component. Let's call this the sprite renderer. Okay, I'm going to double click. The mission here is going to be to render a sprite. Okay, so let's just see if we can draw anything. That's a good place to start. Every single frame I want to draw. So how do we draw? Okay, well, I think it's image.draw. What kind of position data do we have? Anyone know? Let's go x is equal to 0, local y equals 0. And I think the API, right, is going to be draw. And this API, and I'm just giving away everything, aren't I? This is going to be string and then position, x and y. That's it, okay? So it's going to be the string, and let's go robot s, so robot south, and then x, and then y, okay? And that's it, all right? That is it. Now, when we run our game, nothing's going to happen. What's the problem here? Oh, it just exploded. Uh-oh. Why did it do that? Oh, probably because we used the wrong... Oh, component type. Yeah, this is a very common error that actually I should have probably required you to print an error message for. But this error happens when the name of your component isn't the same as the name of the file. Okay, that's very easy. Has anyone messed that up yet? No? Okay, you haven't been writing much Lua then. All right. But this is another thing. Like, look at that. I started making my own game, and immediately I'm like, wow, this error is super easy to make. Instead of crashing the engine, I should probably like print an error message that says like, hey, we weren't able to find this table. Make sure you're naming the table properly. Okay? You can already see the value of actually using your tools, dog fooding your tools. Okay? Let's change the name here, sprite renderer, and let's go ahead and let's try again. Okay? And we're not going to get anything. What's the deal here? What's the problem? What's the problem? Anyone? And if you really understand component architecture, you'll understand what the problem is. I forgot to do something. Okay, we wrote a component. It's supposed to be rendering every single frame, but it's not rendering anything. What's the deal here? This is a really nice component type, but component types don't matter, do they? Unless you do what with them? Yes? We did not. We definitely did not, okay? And so let's go look at that file. When we go to our scene here, we go to scene, basic scene. Oh, we only have the sample component, which, by the way, we don't care about anymore. We don't need it. Let's go to sprite render, okay? And now let's see if we can render something. Oh my gosh, look at that. Heck yeah. Looking good. All right. Looking good. But you see this component, it's actually, the sprite render is pretty cool, but it's not that useful yet. It's very stiff. It's very static. We can't really control, for instance, what image do we want to render, okay? So let's say here that, you know, we got like an image value, and it's going to start as kind of like a, you know, a default value. We can plug in self.image here, and then in our scene file, we can say that image variable right there should probably, let's say it's something like the image variable is going to start off as a robot north, okay? How about that? Well, let's see if the robot's facing our back. Yep, back to us. Perfect, okay. So that's good. But you know what? You still say that this isn't that great of a component, because it's only ever going to render our robot at 0, 0 in the scene, okay? So you say, well, we need a way to change that, okay? What if we did this? What if we had another component that was all about organizing where our object is, and maybe even the rotation of the object and all that other stuff? Well, let's go create a component type. Another classic component that almost every engine will have. This is called the transform component, okay? And we're not going to make the same mistake, okay? There we go. The transform is mostly like a kind of a container of data, okay? So we're not going to have any functions in this component, but what we will have are variables. For instance, x equals 0, y equals 0. We might even have something like rotation equals 0. We could have scale in here. We could have other things in here. But we don't really, I don't think we need those for this game. We'll see. Maybe we'll add them later. And we can say, well, this actor is going to have a sprite render, but it's also going to have a transform, okay? So let's go ahead and change this component that's on here to a transform. And now our actor, our robot, has a transform and it has a sprite render. Over in the sprite render, instead of just choosing what our x and y are going to be, we could ask the transform, okay? You know, we can get the x by going self.actor, okay, to reference our current actor. When we do self.actor, this right here is literally a reference to this object, okay? I mean, that's kind of how you can think of it, okay? And then we want to get this transform on here. And we can do that by doing a get component. And then, okay, what component do you want? I want that transform, okay? Now I have the component, and I can go X. Give me that X, all right? I'm getting this component, and then I'm grabbing that X right there, okay? This is kind of ugly, though. I don't like it that much. So what I want to do is I'm going to cache a reference to this transform. You've implemented these functions, so you know that sometimes they're not the most efficient. They're not the fastest. So we want to cache things when we can. And for this, the onStart function is just perfect, okay? This is going to run once when we spawn in our actor, and we can do this. Self.transform is equal to self.actor get transform, okay? Now, we can just get rid of both of these, and let's say instead of X, we want to do self.transform.x. Now self.transform.y, okay? Now our test here, we've written quite a bit of code. How many of you heard of the iterative design process? Or agile, or whatever. The idea here is that you want to write a tiny bit of code, do a tiny bit of work, and then test. Does it go well? Do a tiny bit more work, test again. If it doesn't go well, you immediately know what the guilty suspects are. You don't have too many lines of code. Another way to think of it, if we wrote 1,000 lines of code without testing, if things go wrong, we have 1,000 lines of code we have to look through to find the guilty lines, okay? And so that's how it be. All right, well, let's go in and let's say, you know what? Our transform is not going to be at 0, 0 because you see X is actually going to be at 1, and then Y is going to be at 1 as well. Okay, so kind of to the southeast of the camera. All right, well, if everything is working, hopefully we'll get something good here. And that's exactly what we get. All right, you notice for a second that our units here, these are scene units, okay? These are not pixels. If we only moved our character over by 1 pixel, like you wouldn't even be able to tell from back there, okay? But we're doing 1 scene unit, which is at a default zoom level, 100 pixels, okay? Soon to be known to you as a meter, because on assignment 8, when you integrate Box 2D, your scene units will become a meter, and it will basically be 100 pixels to a meter, okay? Anyway, here we go. So that's pretty cool. We now have the ability to move things around, which is really great, okay? Now, what I want to do is I want the ability to move things around at runtime. So you know what I'm going to do? I'm going to create another component, okay? I'm going to call this keyboard control, all right? Keyboard control. I'm going to rename the component keyboard control. And then what do I want to do? Well, I'm going to grab a reference again to that transform. And now what I want to do is I want to check if the player is holding down the arrow keys. And if they're holding it down with the right arrow key, I want to move to the east. If they're holding down the up arrow key, I want to go north, okay? Do you remember what the input functions are? Do you remember what they are? Okay. If you didn't know what they were, what would you do? As the developer of the engine, what would you probably do? Like, oh, I forgot, what the calls were. You're not going to look at the assignment spec. Okay, don't look at the assignment spec. That's cheating. What are you probably going to do? Yes?
Maybe go look at your input, like CPP file.
Yeah, you're going to go look at your source code, okay? And guess what? Your users, your game designers who are using your engine, maybe they purchased your engine. What are they not going to do? They're not going to do that. They can't do that. You might have only given them a binary, okay? They might not have access to your source code. They better not have access to your source code, okay? Because that is an honor code violation and will really mess things up for future iterations of the course, okay? But this goes to say that documentation is really important, isn't it? Like having a website you can look up that'll tell you, like, here are your function calls you can make, here's how to use them. That's really important stuff. And you don't realize that until you start trying to build your own game outside of the assignment specs I keep giving you. The assignment specs are where you'll go. You know why? because that is documentation, okay? But anyway, has anyone heard of a tool called Doxygen? So there are tools out there that will analyze your code base automatically and auto-generate your documentation for you so you can host it online. Now, that might be a little bit hard in your case, but not impossible. I'm kind of debating whether we should kind of require you to provide some documentation on your website. You know what we could do? We could actually provide that for you because we kind of know what function calls you have. Okay, kind of. We can guess. And so that might actually be something that we end up doing as a service to you. Anyway, I happen to know that we can do this. Input.getKey. How do I know this, by the way? Anyone know how I know this? We can use input.getKey because we totally stole the API from Unity. That's right. And that was done. We chose to ape a lot of Unity's API and design decisions because Unity is the most common engine on campus, okay? So we wanted that to be very satisfying for you. Let's go ahead and try if we can get right going. So let's say here that we've got a value called local x delta, okay, equals 0, local y delta equals 0. If input.getKeyRight is down, then we're going to go x delta. What is our speed at? This is something that maybe we can customize for different characters. So let's go speed equals, how about just 1 for now, okay? Actually, that's way too fast, isn't it? Way too fast. Because this is going to happen 60 times per second, which means we'll be 60 scene units to the right in 1 second. That's crazy, okay? Let's try like 0.1 maybe, all right? So x delta is going to be self.speed. Okay, actually it's going to be x delta plus self.speed, okay? If input dot get key, and I think this actually, is this capitalized? I think it does need to be capitalized, okay? Get key left, then, oh, by the way, you're already seeing me write syntax issues here. Okay, because this is not C++. Okay, and then x delta equals x delta minus self.speed. Why do we have to do it this way? Why can't we just do it this way? Yeah, Lua does not have plus equals or minus equals, okay? And yeah, I guess it's probably a philosophical thing. It would bloat the engine a little bit, but I don't know. I kind of wish they would do it. So y delta up is minus. We go negative, so it's going to be minus self.speed. Then let's go if input.getKey. Let's go down, then end. And let's go y delta equals y delta plus self.speed, okay? We've written plenty of code, so it is time to use this. Now we have to remember we can't just create a component type. We have to make sure that our actor is going to use that component type. So let's go like this and make sure that we add a new component of type keyboard control, okay? And let's see if this runs for us. Okay, problem with Lua file keyboard control. I do kind of wish it would tell us what line, right? Maybe we, in future iterations of the course, will make the error message a little bit better. I can see the issue right now. Can you see it? So it's easiest to remember that tables are pretty much just key value stores. They're kind of sort of just JSON objects. And we forgot to put a comma here. Okay, imagine being blown up because you forgot the comma. Okay? YAML, which maybe we should have chosen, wouldn't get blown up like this. But actually Lua, yeah, we wouldn't be able to use Lua then. So this is just how it is. Okay, let's hold left and right. Absolutely nothing is happening. Okay, why isn't it happening? This is why you need to test all the time, okay? We're calculating the delta, but we're not actually using the deltas, okay? So we need to actually grab that transform and change the transform's data. self.transform dot x equals self.transform dot x plus x delta. Okay, and then we're going to do the same thing for y here. Okay, and then y delta, and that's how we're going to do it. Cool. All right. And let's go ahead and see if it runs, okay? Look at that. All right, not bad, not bad. Now, one thing that's bumming me out here is that, look at the robot has its back to us. Like, what's up with that? Okay, that's kind of disappointing. And so what could we do? What could we do here?
Can we give the sprite render component and change the sprite?
Yeah, let's do it, okay? When we move here, when we know that our user wants to go down, that might be a good time to tell the sprite render component that it should change its sprite to something else, okay? Right? And by sprite render component, I mean the one right here. This is literally the keyboard control component talking to the transform, but also talking to that sprite renderer, okay? So let's rock and roll and do exactly that. Where is that keyboard control? Here it is, okay? And so what I'm going to do here is we need to get that reference to the sprite render, self.sprite renderer equals self.actor, get that sprite render, okay? I need a reference to it right now. Okay, now we have that reference, okay? We can go into our sprite render and we can mess with this image variable. And that's exactly what we are going to do. By the way, I really think that the robot should start by facing us. All right, it's kind of disrespectful to not do that. So let's make sure that's fixed. Okay, so when we're going right, we want to change that image to robot east, okay? When we're going left, we want to change that to robot west. When we're going down, we want to change it to south, and when we're going up, we want to change it to north, okay? And let's see how this goes. Nice. That looks pretty good, doesn't it? All right, and you can see we're kind of moving pretty fast here. If we were writing a bunch of C++, we might actually be in some pain. We might even be having like compiler issues and stuff like that, okay? So one thing you might say is, you know what, Austin, like, I'm just not feeling the movement, right? I feel like I'm in this void. I want to explore, okay? That means we need a background, okay? We got no background. No background at all. So let's go find ourselves a nice background. And this is where I need some more creative input, okay? What kind of environment is our robot exploring? Is this like WALL-E? We're on like a post-apocalyptic trash yard Earth? Are we in a dump? Where's this robot? We only have so much time. Please, please, please. You know what? How many AAA projects have been doomed by an unclear creative vision? Okay? You need to have a very clear focus on what you want to achieve and the tone you want, okay? So you better get with it. What do you want? Desert. A desert. It's like a desert robot. Oh my God, it's like Star Wars, right? Okay, let's go. I'm liking this already. I heard Star Wars sold a ton of copies. We're gonna need to be extra careful, okay? Because we're gonna actually break some copyright here. Is that how you spell Tatooine? Is that the desert planet? Okay. This is the desert planet. We need a really good image here, a really big one. I want a gigantic image, okay? How do I get a big image? Size, large, please. Oh, can we get like a top-down image? I don't want these sideways ones where we might go into the sky. This one's okay. Is this one all right? How big is it, though? That's pretty big, but I think we can make it bigger. Let's go in. How big is this actually? It is not that big. Okay, I want it to be at least 2 times that big. Okay, and I'm going to go in. I'm going to export this. I'm going to export this as let's go to our desert. Okay. All right. Now the real question is, can we get this off of my hard drive into where it needs to be without crashing Explorer? Where's the desert? There it is. Copy it. And then we're going to go in. We're going to add this in as our second image, okay? It's the desert. Now, how do I get this into my game? We need a second actor, don't we? We got the robot, but then we got a background image. So let's go in. Let's go into scenes. Let's go into basic. We got this actor. The actor is getting pretty big, pretty chunky, because it's got all these components. We're going to come down here. We're going to create another actor. The actor's name is going to be background, okay? It's going to have a component object. And yeah, that's the right, that's the right syntax. By the way, this is why you want to provide a sample scene, a sample component, so that your users can quickly get a feel for how these things are supposed to look. What kind of component should it have? Well, the first one I'm thinking about is I just want another sprite render component, okay? I want a sprite render component, and I want to be able to tell it, actually, this is the syntax. Okay, the type of this component is sprite render, and then we need to give it that image parameter. The image is going to be the desert. So let's go desert, and let's just see how this goes. Oh, it's going to blow up. Why is it going to blow up? Yes? Yeah, if you recall, our sprite render requires there to be a transform component for it to do its job. So we need to also give this background its very own transform component. So type transform, and it'll just be at default 0, 0, which is exactly what we want. Okay, so let's go ahead and let's write some code. All right, we've got our desert, but we've also got a problem. What's our problem? Where'd a robot go? What happened? What's the deal here?
So render the background after the act.
Oh no, okay. We're rendering our background after the actual robot is being rendered, which means that our robot is buried in the sand. Okay? Never to be found again. So this is a problem. We really wish that we had a way to say, hey, render the background like first. Render the background first, and then you're going to render all the good stuff, the robot on top of that background. And so you're frustrated, but then you discover that there is a, let me see here, where is it? There is in our API an advanced version of the image.draw call, okay? Where is it though? This is why you need really good documentation. It's called drawX, okay? Draw extended. And this takes more parameters. It takes the first 3 like normal, but then the additional ones are rotation degrees, scale, scale, pivot, pivot, RGB, and then A, and then finally the thing we actually care about, which is the sorting order. Okay, we could reverse the order of our actors here and probably solve the problem, maybe slightly easier. But we should probably just get used to using this more advanced version of the call, okay? So I'm actually going to copy this and then comment it out in case we want it back later. And then, what was it again? Scale, scale, rotation? What was it? Scale, scale, pivot, pivot. I think, oh yeah, it's 0.5. We changed how pivot works on this homework. So it's much easier to use. So 0.5, 0.5 means center of the image, okay? That's your pivot point. And then RGBA, we just want a basic, normal white tint. So 255, 255, 255, 255. And then we want sorting order, finally, to be something that we can program, okay? So I'm going to put sorting order in here as another variable. The default is going to be 0, and we're going to plug it in right here into our function call, okay? I think this is probably going to work, so I'll delete the comment there, preserving our old work, dead code. Shouldn't keep that around too long. And then I need to actually say, hey, background, I want you to render the desert, but I want you to render it with a sorting order of like -999, okay? So that it's going to be way early, okay? Way early. Let's go ahead and run on, oh my God. Okay, what's going on? Okay, draw X. Number expected got no value on line 13. No, on line 10. Okay, argument 13. Okay, so let's find out here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This says to me that we missed. Oh, I know what happened. Wait, no, I don't. Are we? Where is that one? You're right. It's number 4. We just totally skipped it. Okay. So rotation is going to be 0 for 0 degrees. Okay. Or actually, I think that might. Are the units degrees or radians? Let's find out. It's degrees. Okay. So degrees. That's another thing you want to put in your documentation. Okay. Because people just won't know. This is kind of like you put a bunch of directions into an assignment spec, but you leave a tiny bit out, and then the students post on Piazza or Discord asking for clarification. That happened today, and I still have to go improve the spec. In particular, I think the question was, I can't remember who asked it. The question was, does find all return the actors in a certain order, I think. Or maybe get components. Does that return all the components in a certain order? The answer, I think, is yes, but the spec doesn't tell you to do that. Okay? So that's a problem. All right, well, anyway, let's see if we get those errors, okay? Another thing to point out is the great UX here, okay? Not only do we know that there is an error, but we're told exactly what line the error happens on, and the feedback was great. It told us that we were 1 short. Okay, we were 1 short in our parameters. Look at this. Now I'm exploring Tatooine. Our desert environment. Okay. Yeah, but you know what? I don't feel like I'm really exploring here. I don't get those exploration vibes. You know why? Because I can't really go. I want to know what's over there. But the camera doesn't follow me. So this is a big problem, okay? And so, what should we do about that? Well, what if the camera followed around our character, okay? Followed around our character, and so it could actually explore around the environment. Well, there is a way that we can do this because we have a camera API, thankfully, okay? The camera API, let's go find it. Here it is. It has a set position value. So we could write a component that does all this, okay? What I want to do is I want to do it kind of in a clean way. I want another actor, okay? I want to have another actor. I'm going to call this actor. Oh, what happened? All right. Oh, yes, braces. Okay. I'm going to call this the camera actor. I'm going to give it a component called the camera follow player component, okay? And actually, you know what? We should really make this even more general purpose because what if we want to follow a cutscene or something, okay? I want a component that can follow the player, but it can also follow other things, other objects, okay? So, by the way, we should change the name of our player robot to, player, okay? Let's go and call this component, let's go follow target. Camera follow target, okay? What is our target going to be? It's going to be the player, okay? We want to follow that player. All right, well, we need to go and create that component because it currently does not exist. So let's go to resources, component types. Let's go to, let's go to sprite renderer, okay? Let's duplicate that one. Let's call this camera follow target. And this component is going to be all about telling the camera to follow some sort of target, okay? One parameter that we have on this component is going to be that target that we want to specify. Okay, sounds good to me. When we go and start up our function here, what do we need to do? What do we really need? If we want to follow a target, what do we got to get? Anyone know? What are we going to need if we're going to follow something? This component is all about making the camera follow some sort of object out there.
You need to get the transform object of that target.
Bingo. I want to get the actor with this name, and then I want to get the transform component of that actor. Okay, so let's do it. Let's go local target actor is going to be equal to, you remember how to find an actor? Any actor in our current scene, how can we get it? How can we get a reference? Actor dot, what is it? I feel like most of you aren't very far in the assignment.
Get actor by name.
It's just find. Yep, actor dot find. And we don't want to provide any name like Mario, right? We want to just get and use that variable that we set up, okay? In our scene, this is going to start as the player string. So we're going to find the player. And now what we really need is the transform of the player. I'm going to call this self.targetTransform, okay? And it's going to be target actor dot get component. What kind of component do you want? I want that transform, okay? Because this function is an instance function, right? It's going to use data inside of our target actor. I need to use colon instead of dot. Okay, don't forget about that. You got a quiz coming up. Okay, it's going to get you. All right. So now what can we do? All right. Well, what I want to do is I just want to know if things are working. So what I'm going to do is every frame I'm going to actually print some information just to verify it's working. Okay. Let's go actor, and then I'm going to print the target's name is at, and then I'm going to go ahead and print the x and y. So self.targetTransform.x, and then I'm going to add a little space here. Then I'm going to self.target.transform.y, and then I'm just going to go and run that. I think we actually need to. No, we did add that. We've got the component running, camera file target. We got it on a new actor, so I think we might be good to go. Okay, we got an error here. Let's find out Lua 10, okay? Attempted can get a nil value. So target is nil. Oh, you know why? Oh, this is another big one, okay? This is a big one. This will get you. This is a foot gun. This is on the quiz for sure, okay? You can book it. Here's a free point right here, okay? On the house. What's the problem? What's the problem with target? And this is one of those things, Lua. It's like you ask the Lua creator, like, hey, what do you, why'd you design it this way? And they basically say that, I don't know. What's the problem? What's the problem with target?
Does it like see the target variable in the self namespace and not like the one in the local namespace?
What's happening is that target right here is a global variable, okay? And you wouldn't think so. You're like, wait a second, no way. I'm in the camera file target table, so clearly Lua should understand that when I say target, I'm referring to the thing right there, right? No way, it doesn't at all. Okay, it doesn't know that at all. You have to write self.target, okay? You have to do this. Self.target. And that's how it be. And that's because Lua is a global by default language, rather than being kind of a local by default, which you might be used to in C++ and most other languages. Okay. Anyway, there we go. And as I move, look at that. Look at that. My data is changing as I move around. So this is really good. And what I can do now is I can say, you know what? I'm just going to use that camera API, which was so nice. I'm actually going to look at the set position. Set position is XY. Okay, so it takes X and it takes Y. Okay, very simple. All right. Camera.set position. Self, let's see, self.target.transform.x. And then self.transform.target.y. And we're going to see what happens, okay? By the way, most of the time you want to update your camera after everything else runs toward the end of the frame. So let's go on late update instead of on update, okay? This might be useful. Maybe it's not going to be super important for us. We'll see, okay? All right, and now we're moving around. Pretty cool, huh? Let's go. We can now explore the entire galaxy and reach the edge of the universe, okay? So we have what's starting to feel like a game. We can actually explore. There might be secrets out here in these sand dunes. Who knows what we could find, what adventures we could have, okay? And I want to stop printing this because that was just debug stuff, all right? Now, one thing you might say is, you know what? This camera is so stiff. I want to have like a smooth cinematic camera that smoothly follows us around. Well, how could we do this? Well, what we could do is we could have some more variables on our in our table that kind of preserve where we currently are and where we want to go. Okay, let's go current x. Okay, is equal to 0. Current y is equal to 0. When we start up, we want current x or self.current_x to be equal to where we'll eventually end up. Self.current_y is equal to self.target_transform.y. Okay. Now what we're going to do is we're going to actually calculate desired position x. Okay. That's going to be the location of our target. We're going to also have local desired position y. That's going to be equal to our target as well. And then when we actually go to move ourselves, we're going to use these current variables, okay? So self.current_x, self.current_y. Okay, now why did we do all of this? What's the point? Well, we need to, every single frame, we need to adjust the current x and the current y. Okay, these are variables we're kind of just remembering, right? And this is, you can think of this as the position of our camera. Now, where we want to go is the position of the thing that we're following, the player in this case. What we can apply is something that's known as a lerp. Anyone know what a lerp is? What does it stand for?
I forgot what it stands for, but it like moves something over time.
Yeah. Yes.
It stands for like linear interpolation.
Bingo. That's right. That's right. LERP, linear interpolation. And it is very, very fun stuff. Because we don't have a vector2 data type yet, we can't just call a function really easily to make it happen. But we can do some math. Okay, we can do some math. We can say that, for instance, desired position x is going to be equal to desired position x. We're going to change this value. Or actually, no, sorry. I got that wrong. Self.current position x is going to change, okay? It's going to change by this amount. Desired position x minus self.current position x times 0.1, okay? Now, this might look really strange to you, okay? But what is this right here? This quantity in the parentheses is the difference between where we want to be and where we currently are. It's like the step we can take to get to the door, all right? If we move that amount, we'll be where we want to be on the next frame. But we're going to actually multiply that by 0.1. So we're only going 10% of the way to where we want to be, okay? And so basically what's going to happen is every frame we're going to move 10% of the way there, which is going to slow us down and smooth things out over time on the x-axis. We're going to do the same thing on the y-axis. Now, this actually isn't the way you would typically do a lerp, because this might look a little bit weird because the axes are being treated kind of independently, and you normally wouldn't do that. If you had a good vector 2 type, and I'm kind of regretting not putting the vector 2 type into homework 7 now, it's there. There is one, but it's got no operations defined on it at all, so it's kind of useless. Anyway, kind of too late now, unless you want more test cases. Anyone want more? On homework 8, you'll get a real deal vector 2 that's actually amazing, okay? And you'll like it a lot. Anyway, so hopefully, we're going to see, but hopefully we will get something a bit smoother than last time. Look at that. Look at it. It kind of smoothly catches up to me. And you know what we could do, which would be crazy? We could go up and say, you know what? We want the ability to control how smooth it's going to be. So let's go ease factor. By default, it's 0.1, but this can, of course, be changed. We're going to go ahead and not hard code 0.1 anymore. Now it's a variable. So our game designers or people who use this after us will be able to really do some wonderful stuff, okay? I'm going to go ease factor. It's going to be 0.02. This is going to be super smooth, isn't it? 5, let's see. Oh my goodness. We can almost run away. Okay, we can almost run away out of the camera. See ya. Okay, bye-bye. Okay, so this is pretty cool. We can move around. I don't actually want it to be that sloppy. I want it to be a little bit more stiff. 0.1 is fine. Okay, and so one question is, well, what should we do in this world? Okay, should we be able to shoot something? Okay, should we be able to? Maybe a fireball, okay? A fireball for a robot to spit out. Let's go ahead and let's say, you know what? I want to draw a fireball, okay? I want this to be, how big is our robot? We want it to be, yeah, let's make it like 48 by 48. How about that, okay? Okay, so about what? Let's go like that. Okay, I'm going to go ahead and make this, give this alpha. I'm going to delete this. I'm going to draw a nice fireball, okay? Okay, and then go in. All right, so there we go. We got ourselves a fireball, okay? And we're going to bring that fireball into our image folder. So where's the fireball at? There we go. Let's go in, images, there we go, fireball. And now we need to spawn that fireball. Now, if you think about it, we don't want to just create an actor here, okay? We really want to be able to spawn as many fireballs as we want. We can't just put it in the scene because it might come in dynamically, for instance, when the player presses spacebar. And so what we got to do is we got to create a new actor, but we're going to create it in the form of what? What should we do? Anyone? What should we do? We want to create an actor that we can spawn and copy infinitely, yes?
We need to make a template.
Yes. So we're going to create a folder called actor templates. This is a special folder. Our engine will automatically go in there. And let's see here. Let's create a new text document maybe. Can we call this, let's call this, just Fireball, okay? And I think it's .template, right? Unfortunately, Windows is really frustrating about this. Windows is, oh no. Oh, it strikes. Oh, brutal. Let's see here. So you ever notice how it's kind of hard in Windows to actually make types that aren't like, don't have .txt at the end? Has anyone ever had that problem? So this looks like fireball.template, but it's actually fireball.template.txt. And that absolutely drives me nuts. Yeah, I'm not sure why, unfortunately, it's having these issues. I think, let me see. Let's see. Maybe it's just really bad drivers or something. Okay, what I'm going to do is a technique here to try and fake it out. Actor templates, I've got my fireball right here. I'm going to actually just drag this in, straight in here. Okay, there we go. So I'm going to copy and paste this. We now have our actor right here. I'm going to call this fireball, and I'm going to give it some components. It does need to have a transform, but we'll actually set the transform's position when we spawn it in. It has a sprite renderer, but it should really be showing the fireball in all cases. It should not have keyboard control, okay? Yeah, we might also want to have another component, but I'll save that for a little bit, okay? I want to save this. Does anyone know how to change where we save this to? Anyone know? File save as sounds good to me. Let's save this as just like .template. Oh, it's not working. It thinks we want the .txt extension, but we do not want that. Let's go to all files. Yes, save that instead. Okay, good. Now we just need to get rid of this, this right here. Good. Okay, so now what we're going to do is we are going to go back to keyboard control. Okay, keyboard control is where we detect inputs. Let's go to if input.getKeyDown, okay, space, then we want to do something. Riddle me this. What's the difference between getKey and getKeyDown? Quick, yep, Jacob?
Get key down is just the frame that it gets pressed.
Yeah, so getKeyDown will not be true if I just keep holding the spacebar down. It's only going to be true for that first frame in which I've pressed the space bar, okay? I want to create a new actor. So you know how to do this? The API that our engine provides under the actor class has find all. It also has instantiate, which is what we want. Instantiate, all it does is take the name, a string of an actor template. So that's great, super easy to use. Okay, you might choose like create. You might choose to call this create instead of instantiate, because instantiate is actually kind of a word that many people don't know. And it's also, create's just easier to type, it's shorter, easier to say. And so if we were designing a new API, or like a really awesome new one, you might go with create instead. It also really is a good match for destroy. I'm not sure why Unity didn't use create, like gameObject.create, right? Okay, so we want a fireball, and then once that fireball is here, we want to do something with it. We got to change its position. So we're going to actually capture the reference to that fireball. I'm going to call this new fireball, okay? Now this actor has a component on it. It has a transform. So we're going to get that transform. New fireball transform is going to be equal to new fireball dot get component, okay, or colon get component. I want your transform, please. And then we're going to take that new fireball dot transform dot x. It's going to become our transform dot x. So self dot transform dot x, and then new fireball transform dot y equals self dot transform dot y. Yeah, hopefully that's going to spawn us some fireballs, okay? But let's see. Okay, I'm running around, press space, look at that. Let's go. Heck yeah, this is awesome, okay? All right, so we're kind of running out of time. Now, I could shoot these fireballs, okay? And I could write some code to detect collisions between the fireballs and some enemy actors. If I wanted to, what I could do is I could not only spawn in the fireballs, but I could also add them into a table, okay? So table.insert, which table do you want to insert into? Well, we don't have a table yet, okay? So we can create one. Self.fireballs equals table, no, not self, okay? We want this to be a global table so anyone can access it easily. So fireballs becomes a global table, and then we can insert every fireball that we create into that table. Okay, so now everyone can grab and iterate through the fireballs, and they can check, for instance, if a fireball is close to me, I take damage. Okay, question?
Wait, so that makes it global for every component?
This makes it global to the Lewis state, okay?
Oh.
As soon as you run this right here, it doesn't look like it necessarily, right? If you're in the C++ mindset, this looks like a local variable, but
That's
it's
so
not.
dangerous.
It is. Yeah, it really is. You can make this a bit nicer by saying if fireball table doesn't exist, then create the fireball table. But basically, we've created a global list. We're inserting fireballs into it, so we could check that later if we wanted to, okay? But we are not going to write that code. We don't have enough time. One thing I might want to do is I might want to say, hey, fireballs, you know, you should have a component on you that is like, constant movement, okay? This is a constant movement component. Oh, by the way, that's not how you write a component. No, that's not at all, okay? This is how you write a component. You create a new component, then you give it a type value, and then you say, there you go, okay? Constant movement, okay? And a constant movement component, we have to go actually create that component type. So let's go into our component types. We're going to go to, I guess keyboard control is kind of similar to what we're going to do. Let's call this constant movement, okay? And then we're going to create that new component. It's going to be a pretty simple one, all right? Let's go and create some variables. Let's call this x speed equals 0. Let's call this y speed equals 0. And then when we don't care about onStart, actually we do. We need to grab our transform, right? So we're going to do that. And then, all we're really going to do here is every single frame we're going to update our transform position. Except in this case, it's going to be a self.xSpeed and self.ySpeed, okay? See, a very simple component. And now we can set our x speed and y speed to change how the fireballs will move. So here's what we're going to do. We know that our new fireball that we spawn in has it has that constant movement component. So what we can also do is we can say, you know what? Let's grab that CM let's go constant movement. Okay, it's going to be the fireball get component. We want that fireball's constant movement component. Now we have it. And so we're going to take this movement component. We're going to go .xSpeed, okay? We're going to set that. We actually have to be careful, right? Let's set this to 0.1 for now. And we'll set the y speed to 0. Let's test this really quickly just to make sure it works. Our fireball will go off to the side. Look at that. We got our shmup back, okay? It's just more exploratory. But there's one more thing I want to do. I don't want to shoot just off to the right all the time, okay? And so one thing I'm going to do is I'm going to go in and create a little variable called direction. It's going to be just a character, okay? We begin facing south, so I'm going to make that S, all right? When I move to the right, I'm going to go self.direction equals east. When I move to the left, I'm going to go self.direction equals west. When I go down, I'm going to go self.direction equals south. And when I go north, I'm going to go self.direction equals north, okay? Now, what I can do is I can go in here and say, you know what? When I create the new fireball, I'm going to change its movement, its constant movement component based on which direction I'm looking at the time, okay? So let's go self.direction is equal to north. Then, okay, we want to do some stuff. If it's north, we're going to go, how about negative 0.1, and then on the x-axis, we will go nothing. We'll go nothing, okay? If we are instead east, then we want to go 0.1 on x-axis and then nothing on the y-axis. If we are going south, we want to blank the x-axis and go 0.1 on the y-axis. And then finally, if we're going west, then we want to go negative on the x-axis and 0 on the y-axis, okay? Hopefully I got that right. We're going to find out. Let's go ahead and let's move around a little bit. Look at that. Oh my goodness. Is this a game or what? We're knocking down features like it's nothing. okay? Imagine for a second that you can't write C++. And there are many reasons that C++ might be very slow for you to write. You're all getting very good at C++ now. But imagine for a second that it was the first day of lecture, okay? And being asked to implement all this logic might take you a while, okay? Here, however, Lua is a pretty simple language. Yes, there are some footguns, but once you get used to them, you can move very fast. You don't have to worry about these crazy compiler issues with the terrible ambiguous messages and all the things that can go wrong, okay? You don't have to worry about compilation. You can just quickly get back into it. You don't need the source code, okay? And so we've made this basic game, which is really the start of a pretty cool exploration game, if I'm being honest. And it didn't take that much time. It only took an hour. And guess what? I spent a lot of that hour like talking to you, okay? And trying to set things up, trying to walk you through what's going on. Imagine how quickly I could have made this if I wasn't teaching at the same time, if I didn't need to stop and explain stuff and remind you of the APIs and stuff like that, okay? We could have moved way faster. Imagine, again, if we had an editor, like a visual Unity style editor. So we didn't have to open up and text edit everything every time we wanted to add a new component. We could just click a button instead, okay? And so you see that you've actually, okay, as soon as you're done with homework 7, no joke, you've got the sauce, okay? You got the stuff that you need to have a pretty legit engine. Because, like, this doesn't look like much, but imagine if we had a really great art style here. Imagine if we had some time to throw in some good music, okay? You can seriously build stuff that looks legit, okay? This is starting to look legit with the nice camera movement that's also smooth, right? Next week, and this is partially because we're running out of topics to talk about on homework 7, we got delayed. We delayed everything so much that it's like we've been on homework 7 for an eternity. Have any of you heard of coroutines? Okay, next week I'm going to explain to you what coroutines are. I'm going to show you how you can bring them into your engine without writing a single additional line of C++ code. Imagine this for a second. Imagine if you gave your game designers a starter project that came with a really nice sprite render component already there for you to use, and a nice transform component that your designers can just grab. We wrote both of those. But imagine if we made a really good decision with our engine and we said, you know what, we're just going to give people these. Okay, they're great, easy to use. Imagine if we did that. Okay, we could move even faster. All right. In fact, you could even move those components into C++ if you wanted to, make them built in, make them even faster performance wise. And we could just do some crazy stuff. Anyway, I hope you're getting excited. Like, you got something that is legit real, okay? And I hope that in interviews and stuff, you'll play up like, yeah, I went in and I built Unity internals. Like, the fact that components can talk to each other, like the get component function, you know that function? I made that in my engine. Let me tell you about it, okay? I had to organize all of my actor references, and I had to use Lua Bridge to set up the references just right so that our Lua users could run the right functions. And I put them in this container so it would be performant to look things up every frame if you needed to. I don't know. I think that might do you well, okay? Now, like, I'm not going to share any info, but I have confirmation that people in this course have already gotten jobs at game studios by talking about their engine. That is not a joke, and that makes me so happy, okay? Anyway, I'm super geeked about this. I can barely believe it myself because I haven't written an engine before this course. And man, I'm like, yeah, I already bought the domain for what I'm going to name the engine. I bought it last night. Can you guess what I'm going to call the engine? Okay, I'm going to give you, this is a final thing, final tangent, okay? If you go to Wikipedia game engines list, okay? Lots of people view this list every single day, okay? Now, I learned this the hard way, but when you name something, you put it at the top of the alphabetical sorting order, and you're going to get more hits, okay? Some things are going to be really nice for you. And so I want to be up here, but I also don't want to name it in like a way that makes no sense. So I'm probably going to name my engine in here that we designed for the course, and you'll create your own name because you're going to have a custom variant of this engine with new features, right? That's the final 2 weeks of the course. I'm probably going to call it the A2 engine for I do live here and I like this town and I love this community. So anyway, that's probably what I'm going to call it. It's going to be the world's most closed source open source engine because you can get the code. You can look at the code, study the code. You can use the code for anything, but you can't disclose the code publicly because otherwise students in the next semesters will grab the code, okay? So it's kind of open source, but kind of not. Maybe it'll be the UMich license. Forget the MIT license. This is the U of M license, okay? Okay, everyone. Thank you so much for coming. That was really fun. Maybe we'll do it again sometime. And, yeah, office hour starts now. Get cracking on homework 7. We'll help you out, okay? All right, everyone. Take care. We'll see you next time. Yeah, have a good weekend. Bye-bye.